Okay, guys, today we're going to talk about the differences between resistors in series and those in parallel. You can tell a resistor in series or parallel visually inspecting the circuit. So if we look here, we have these all three series that all are connected and make one path. There's one path for the current to flow. Therefore, they're all going to share the same amount of current. This means that if one of these resistors fails, then we have an open circuit. The equation to calculate their equivalent resistance of resistors in series is simply the summation of those resistors that are all in series. So it's R1 plus R2 plus resistance 3. Okay? We can tell if a resistor in parallel or not. Alright? By determining whether or not both ends are connected at the same node or junction. So if we look here, on this example, we have this top wire, and each one of these nodes, or I should say each resistor, is connected to the same top wire and also the same ground here, the same bottom wire. Okay? So these three resistors are all considered to be in parallel to each other. This means that if one of the resistors fails, it's okay, the circuit will still operate because there's multiple paths for the current to take. This also means that we have potentially different amounts of current in each one of these loops. Okay? The equation for the equivalent resistance for resistors in parallel is 1 over the equivalent resistance, and then that is equal to 1 over the sum of each individual resistance itself. So we have, in this example, these three resistors, and we would keep going on if we had more for these resistors in parallel. Now this equation can be simplified if we have 2 or 3 resistors. Alright, so it can also be simplified as simply the equivalent resistance is equal to R1 times R2 over R1 plus R2 for 2 resistors. And it can be simplified as the equivalent resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So you can see here we have our formulas for resistance in series and resistors equivalent resistance in parallel.